some really interesting work. Our next presenter is Professor Farzad Khosrowshahi, who is the Dean of Engineering and Sciences at Victoria University, Australia. And he is Professor of Construction IT. Now, Farzad and I have known each other for a very long time, and every time I have a conversation with him, he says something really interesting. So when I invited him for this presentation, and I said, "Give me the title of your presentation," he came up with a very strange title, and that's why it has got me more curious. So the title is Humans, Physics, Engineering, and Chemistry. So Farzad, it's all yours. I'm sure it's going to be very interesting. So I look forward to hear what you have to say. Thank you very much, Farzad. It's all yours.
Thank you very much, Muhammad. You missed the God. It was God, humans, physics, engineering, and construction. And presumably you can see the screen. Thank you for the invite. I appreciate that, and enjoyed the speakers so far very much. And good morning, good afternoon, and good evening from Australia. Now, my talk is about God, humans, physics, and engineering. Trying to be a little bit out of line, maybe half philosophical, half otherwise. And but basically, when God creating the universe must have been a serious challenge for him, because he took the seventh day off, and it's not surprising, because according to Penrose, God had to aim at a very small volume of space of possible universes of about 1 over 10 to the power of 10 to the power of 123. So it was a very tough job for God. And there is no evidence that before those 7 days, God did anything else. And there is no evidence that God took up any other project after those 7 days. He must have been preoccupied with us as his only project. And yet we turn out to be a bit of disappointment for him from day one. And you've all heard the stories. Even Saint Augustine, the famous bishop of Hippo, he said most people would prefer sex to pray to God. So we would understand if God is not happy with us. So he decided to punish us in a most sophisticated way. He decided to punish us using the very same tool he used to create us. He unleashed the second law of thermodynamics on us. Now, entropy is the measure of randomness or disorder of closed systems. The amount of entropy of a system will always increase. It always go from good to bad, if you like, if you want to put it that way. Now, take a look at this pile of sand. This could exist in many different forms. It's very improbable for this pile of sand to just turn out to be like this on its own. But it does need some energy for us to put into it in order to convert that into the castle. And in doing so, we create some heat, and that heat goes into the universe and changes the entropy of the universe. And that's the price we pay. But the other way around is very probable. You leave a castle like that for a week, and then for hours, and you end up with that. So it always goes from that to this, from order to disorder. And therefore, even looking at from information side, energy, information can also reduce entropy. Look at all these desperate letters. They can exist in so many different ways. What is the chance of all these letters to come together in random and to become Shakespeare's complete work? Very unlikely. The intelligence signals that converts these letters into work of Shakespeare actually reduces entropy at the cost of generating heat to the universe. Now, basically entropy is our punishment, because we have to continuously use energy and information to fight at every step of our existence. It's a big challenge that God gave us to deal with. But how did we measure up against God's challenge? How did we do? Well, according to Steven Pinker's 40-odd graphs, we are not doing too badly, actually. Let's look at some of them. Life expectancy gone up significantly since 1760 all the way to 2020. Child mortality coming down, child death coming down, famine death coming down. GDP per capita going up everywhere, world income distribution becoming quite normalized, and extreme poverty coming down, social spending going up everywhere, population and energy growth is going up, carbon intensity is basically going down, great power wars coming down, battle deaths coming down, homicides coming down, car death, pedestrian death, plane crash, executions, and the racist and sexist opinions are all coming down, and rape and domestic violence are coming down, and basic education is going up, IQ gains going up, global well-being are going up, and retirement, people are becoming more chance of not being retired too early. Percentage of spending on the necessities is going down significantly. Cost of air travel is going down. International tourism going up, and nuclear weapons are going down. So, how do we do all of this? This is a big challenge. How did we manage to do this? For 2 million years, we were upright. We had the necessary brain and the body, as we do basically now, and yet we remained very insignificant. What happened that changed things? So how do we do it? Well, there seems to be two ways of answering that. One is myth. In 1992, I saw a movie, Power of One. It was about apartheid. And then there was this black guy, boxer, who had a friend, this white guy, boxer, they were friends. And the night before, the apartheid attacked them very badly. And then at one point, the black guy said that they came because of the myth. You are now part of the myth. They will come again because of the myth. And I believe in magic. I believe in future. I, I didn't fully understand this, but I thought there was something deep about this. So I started finding more about this. I started reading Joseph Campbell, who's an expert in myths. He's got some really good comments about myths and the programs and all that. So he says myth is a boundary between conscious world and world of dreams. We align ourselves with myth where magic is real. I got really interested in that, but even more confused than before. I also looked at other people about myth. Again, good, but I was confused until I met this guy. Well, I didn't meet him, but I read his books. And then Yuval Harari, reading these books, the three of his books, I appreciated the power of myth, helping us beat all animals and all other humans through gossip, fiction, myth, even lies and deception. It gave us ability to cooperate on large scale, telling stories that people believe in, creating a dual reality, physical and imagined reality, where other animals cooperate on the basis of 15 animals at a time. Other humans, Neanderthals, etc., cooperated on the 150 at a time. We managed to cooperate around myths in millions. We don't even know each other. And yet we go around. If the myth can be a dollar, could be religion, could be organization, could be God, could be anything. But we have the ability to do that and mobilize ourselves. So myth actually did help a lot. But what else? Because myth is not enough on its own. For 2 million years, we had the necessary biological equipment. Okay, we invented fire, and that helped our brain to become a little bit bigger. But for 58,000 years, during the cognitive revolution, little change. We relied on evolution and the survival of the gene to drive us forward. And for another 10 years, the agricultural revolution allowed some progress. We built bigger communities, empires, and then pioneering stuff like creating money, inventing writing, etc. But again, the development were not that significant. But as Jeff said very clearly tonight, it was the last 400 years we made the big difference. We've been through 4 industrial revolutions, and now we began to notice the differences. Now we are bypassing evolution. We don't wait for evolution anymore. If you want to run faster, if you want to see better, if you want to have lots of chocolate without having a teeth problem, okay, we just invent glasses, binoculars, and the cars, and we go to doctors and use fluoride. We're bypassing the evolution. We don't wait millions of years for that to happen. Now, and of course, we are in the 4th industrial revolution, as Mohammed and others have referred to, integrating big data, Internet of Things, robotics, augmented reality, cloud computing, and additive manufacturing, cybersecurity, and all that stuff. These disruptive technologies have radically changed our lives. But what made all these things happen? What was behind all of that? Well, science, of course. Everyone looks up to science. Even Trump, who dismisses environmental mitigation, says scientists will solve the problem. And he actually may be right, because it was science which helped us to battle entropy to meet God's challenge so far. You know, if science eventually harnesses unlimited safe energy, we will enslave entropy, our entropy forever, not the universe's entropy. Right, so what is science? I would like to think or believe that it's all about physics. You know, chemistry is the study of matter and its properties. What is biology? Everything in the universe, including us, is made up of 4 particles and 4 forces, and that's it. The whole thing is made of all these 4 forces and 4 particles. Life itself, according to Albert Zint, is nothing but an electron looking for a place to rest. Medicine is all about physics. You know, psychology is a reflection of our biochemistry and senses. IT and computers are about machines, physical machines, and pattern recognitions. Music is all mathematical patterns defined by data. Politics is all about economy. Economy itself is about means of production. And as Jeff said, just imagine what steam engine did to the world, and that followed after that. But what is physics in action? The physics in action itself is engineering. Physics itself is a concept. It becomes humanized only if we apply it. Now, and when we apply it, we will see the beauty of engineering, solving people's problem and fighting entropy. If God was an engineer, he would have designed all the flowers black. All the plants would be black, because that would have saved another 15% energy through photosynthesis. But then God is a bit of an artist. But then so are we. Look at this. So beautiful. A combination of beauty and functionality. Now, I'm an engineer and I'm proud of it. We all say the same thing. Can you imagine the world without me, without the engineer? You know, can you imagine Jimi Hendrix without his guitar and all these chemical products that bridges and structures and traveling to the moon, and then the medical equipment and computers without quantum mechanics, selfies without the mobile, and all these movie stars without the camera, and then all the scene through the machines and the harnessing powers and transportation equipment and you name it, nanotechnology and computer programs, and even medical science. Can you imagine that without engineer, etc., etc.? And of course, Industry 4 has already taken us to the next level, bringing all data together without human interaction. And also Industry 5, as Mohammed said, is upon us. It places greater importance on human intelligence and beyond that. And I will allude to that in a second. So, but this is just a beginning. It's not the end. Even Industry 5 is not the end. We are not very far from some radical changes, I believe, in the future. With humans becoming more data-centric, the Internet of all things may become the end in itself. In 2017, Google's AlphaZero AI started with nothing more than basic chess rules that you would teach to a kid when he wants to or she wants to start learning chess. In 4 hours, AlphaZero taught himself herself how to play chess by playing against herself. And in 4 hours, it learned enough to be able to beat the computer, the human, and the computer-human combination systems, all of them, in 4 hours from nothing. And very, very little computing power. We are now playing God. We are the intelligent designer ourselves, but we are possibly paving the way for our own extinction. We will soon have the technology to genetically design our children, and if that happens, then who cares about children? Because they're no longer my genes to protect. Where are we going with all of this? Okay, it's You know, if you look at the old civilization, they looked into stars to get their answers and actions. And later on, we listened to religion in order to get our answers and define our actions. And then when industrial revolution came and humanism came, we started looking to inside our own heart to get answers. And now data and systems make decisions for us. My gene, my hormones, my biochemistry, neurons make my decisions. These are better detected and analyzed by systems than myself. Facebook is just the beginning. Once connected to our senses, the result is total dependence on the systems. SatNav, we all use them now, but just imagine the future SatNav, which is connected to everybody's senses and everybody and everything that is out there. There's no way you can go around without a SatNav. Even dating sites, of the future. I mean, they would know who's the best person for you to marry, much better than you know how to do that. There are serious political implications. Churchill used to argue that capitalism is the worst system except for all the alternatives. Hitler said the capitalism, you called it something else. Capitalism has values, but only I can define what those values are. Margaret Thatcher believed in values, but she said that capitalism is immortal, is the only system that is there. Don't think about alternative. With George W. Bush, we had to decide either to change our behavior or change our values. And by the time we got to Trump, it became clear that we do not need to have any values at all. And that is what's becoming difficulty because the political implications of 5.0 and even beyond 5.0 is significant. The fate of humanity as we know it is at stake, in my view, and many others out there. We need the right politics before we enter the new era. But what about construction? Construction is a bit of a sweet and sour. We have ultra and many creations worthy of admirations. But we also have a bit of a dark side, a bit of a slow industry, if you like. Despite all the achievements, it is difficult to claim that we have been at the forefront of scientific achievements. It's true. We had challenges, fragmentation, project uniqueness, geographical dispersion, but challenge is the mother of invention, and yet we have to wait for others to meet a lot of our challenges. So many of concepts that typically define our industry have been addressed by other industries. Let's take a look at some of them. Value management, you all teach them, many of you, okay? But it was came out of manufacturing 1942 by General Electric, World War II. Risk management, it came after World War II by the financial sector. Work study emerged in 1881 by Taylor's work, and then in 1969, ILO produced an introduction to work study. Project management, for God's sake, our best thing. CPM by DuPont and PERT by US Navy and Polaris missile. And but okay, project procurements, they belong to us. I agree, but they all came out of a problem. Every time we had a problem, we designed a new project procurement. And that's why we have so many of them. And then came BIM with a lot of promise. It is a philosophical and technological wonder and everything in between the two. It applies, it's got a wide breadth of application of the whole project life cycle, and it offers seamless communication. Technologically, it's extensive visual and analytical capabilities, and with enhanced project management capacities, and also facilitates integration of a wide range of technological and virtual prototyping and simulation tools, and it enables integration into internal and external data resources. But by far, the BIM's main selling point, by far, the best selling point is its collaborative working. But we are stuck here at level 3, okay? And the question is, why are we not here? We need a truly collaborative BIM. to make everything happen in our direction, in our industry. Perhaps the theory of everything in construction is what we need to look for. Uh, as we would like to have one in physics, maybe we should have one in construction. Now, one which would demand us to behave in a collaborative way rather than being dependent on trust and goodwill. Let's look at this example, simple example. Please wash your feet before you enter the pool. If you use this, then only 15% of people will wash their feet, and we need to police that. If you use this, then 40 to 50% might wash their feet, and we need to police that. But if you put one of these, 100% will wash their feet, and you don't even have to police this. Not, we don't have to rely on trust and goodwill. We have to rely on systems that make sure things happen. Now, BIM level 4 could be that theory of everything that we're looking for. It embeds all these missing tools, risk value, project management, etc., within it rather than attached to it. Even when it comes to supply chain maturity, it's where the supply chain is at maturity level 5, where supply chain is integrated, extended, not just managed, where supply chain is highly organized and structured, where cooperation takes at the process level, okay, and where supply chains compete with supply chains, other supply chains, rather than members of its own supply chain. Not many of these has happened. In fact, some in 1998, a report came out building down the barriers, bringing down the barriers. It was fantastic work, but nobody took that serious. Now, no theory of everything is complete without looking at uncertainty. What about uncertainty in construction? Well, most of it is in the maintenance area. There's a great deal of uncertainty out there. Now, and we know that in maintenance we got on failure, preventative, etc. But they're all categorized under two. Either they're too soon or they're too late. What we need is just in time solution to the maintenance. In order to do that, we either have to travel through time or live through the building twice. Now let's look at the possibility of traveling through time. Just imagine this is the space and time coordinates. And just imagine Jesus was born at that time, and then he was considered as the origin of the time and space in that facility. Now, if you move at the speed of light, then things will happen in that direction. If it go faster the speed of light, you can go there, but we can't travel fast the speed of light. So we are confined to this cone. This is our Earth, Jesus, space-time cone. We cannot understand or realize what's happening beyond that space. Now, if Jesus grew up and become 33 years old and then he was crucified, and if at that time somebody started traveling pretty fast around our time-space cone, it would be traveling around across this line. And because of Einstein's first postulate that the speed of sound is fixed in all frames of reference, therefore something else must give, and that is the time dilutes and also object shrinks, space is affected. So anyone along this, depending on the speed, would be an equal size distance to the original Jesus birth. Now, so the same person like this could be there on the same line, etc. Now imagine when Jesus was born, there was another Jesus in another planet, at the same time born in that planet. They would not be aware of us, we would not be aware of them. But what happens, they've got their own time, planet cone, space-time cone. And imagine somebody else is traveling fast on something very fast near the speed of light, and they would have their own curve of equal distance of time and space distance from the origin. And somebody traveling there would be traveling up and there, etc. Now, looking at this curve, these were born at the same time. And this person can be here and can be there depending on the speed. So this person can see Jesus past and can see Jesus future before and after Jesus, theoretically speaking. This is to the point that Brian Cox said that our past and our future is all there. I love it. Of course, they cannot do that. And then maybe we have to wait for the quantum theory of space-time before make some sense of this. But for the time being, we can't do it that way. So in order to have a just-in-time solution, we cannot travel through time, but we can live through it twice. Well, how can we do that? Only in a virtual environment. I'll give you an example. We have realized that the objects' behavior in terms of their behavior and in terms of their life death situations is defined by a probability distribution function like this. Okay, let's look at a couple of examples in degradation of lighting system and the flooring system. A light system is affected by 6 main variables like this, which we can, put a code in VRML and represent it in red, green, and blue based on the lifespan as well as their status, whether they behave, perform in such a way, or whether they die or otherwise. Now let's look at this. This VRML suggests that this light is like this. We change the parameters of the VRML, it becomes darker. And this is just parametric changing. Okay, let's look at this meeting room. It's good. After a year, some dust and things get there, and grease get there. It becomes lighter and darker. Let's look at the corner of this. Look at lights here. The lights here. After about 6 months, these lights die, and these rooms become darker and colder. So these are simulating what might happen. So to be able to live in a building twice. Now, the other example is a flooring system. The flooring system is much more complicated because we also need to know the pattern of usage of the flooring system before we can visualize the degradation. The floors, they don't get degraded everywhere. They get degraded in different patterns. So in my project that I looked at, a lot of people were involved, including an anthropologist. An anthropologist said that, look, there are 2 ways of looking at this: either activity system, where we look at the where we place themselves in the center of, we look at the sequence of activities, or we look at the behavior of the patterns of the behavior. This is the one which we picked up and built on that, which tells us that they like to put people in the center. People like, or a species would like to place themselves in center of things, but at the same time keeping a distance from others. To mathematize that, this is the graph of one person, want to be in the center of things, and this is 2 people, and the center will be the distance, and this is 3 people, and this is integrated over the whole population, the whole colony, which is expressed by this simple expression. Now, if you present that in graphical, in 2-dimensional space, the intensity looks like this. Looking at top, it looks like this. And if you create a corridor, like a corridor in your office, if it's a double-ended corridor or a single-ended corridor, the pattern of usage would be something like this. So if you look at a version room, if you like, with one thing in the middle and then 3 corridors, the pattern of usage would basically look like this. And the next challenge is, of course, to be able to visualize that, because that, after all, we want to live in that space twice. Now, this is the very old carpet. This is brand new carpet. And we want to map this pattern on top of these 2. And then it's a very simple algorithmic expression or statement, which can convert this into that. Now, here's an example of room with 2 doors, superimposing that pattern on the carpet. I mean, you probably can't see that as good because this is degraded, this is brand new, etc. And this is with the table in the middle. My final screen, the summary. So what is the future of construction? I'm speculating here, don't kill me. What do we mean by future? Some people think things will radically change within the next 20 years. And some people say 50 years, but a lot of people agree that there is some significant things are going to happen. 2 million years being around, suddenly the last 400 years becomes so significant. In terms of design, in terms of planning and regulatory stuff, in terms of labor, in terms of maintenance and all that stuff, who is going to do it? Us? Genetically improved superhumans? Cyborgs? Or systems can decide for us? You probably recognize these designs by Geary, architect from American architect. Up to this guy, we used to use technology to be creative and innovative. But he started, I believe, there's no alternative. I think he turned the whole thing the upside down. Now we are helping computers to be creative. Now, computers do the things for us. They have better abilities to do that. So, do we need any planning regulation? No, everything is now, we don't need project managers anymore. We don't need supervisors. We don't need accountants. We don't need managers. We don't need any of these roles because once things are algorithmically defined and laid out there, then things will happen automatically in a much better and more sophisticated and efficient manner. Do we need laborers? Well, I'm not sure because we now have robotics. We now have by now I mean in the future, we now have cyborgs, and the cyborgs. These are the things of the future. So we don't know. Do we need any of these? Do we need? And who are the people who are going to be running? So we need to have some discussions. My final word is that. Um, well, even looking at our children, do we need universities? Because in the future we can be designing our children one gene at a time. So why do we need to train them? And so these are our speculations and derogatory statements. My final statement is that is there a need for Homo sapiens anyway in the near future? Thank you very much.
Thank you very much. Anyone with any questions, please, if you type it in Q&A. We have one question. What is the next industrial revolution after 4.0 and 5.0? How long it takes to achieve to that point?
Dataism. Yeah. Dataism. That's when data takes over everything. That's when systems, when algorithm, they know us better than we know ourselves. They know us internally and externally. They know us everything around us. I'll give you some simple example about SatNav. Just imagine if SatNav is extended to realize how your body is behaving, how your feelings are, and then not only my feeling, it knows the feeling of everybody in my vicinity, and then it adjusts all the feelings and finds the best route for me and for the rest of them to get there when I really want to get there. But what do I mean by really? I don't know what I really want, but the system, they know what I really want. So when we get to that position, that's what I'm saying. That is there a need for our species? Because when that happens, even when the genes disappear, we don't care about children. Where is the survival of the gene? Which gene are we thinking about survival? So this is what I would think, that when systems and when the data take over our life, and we can see that Trump was elected by Facebook and Cambridge Analytic. We know that Brexit was heavily dominated by that kind of decisions, and this is just the beginning of it. It's my opinion, and many other people out there.
Thank you very much. Any other? Let me pick one more question. One question is, what is the most mature technology nowadays? I'm assuming this is in general.
Two quick words: genetic engineering and AI, in my opinion.
Well, with that, I would like to thank you, Faz. As always, it has been a pleasure, and thank you very much for taking the time and being up so late, so you can go back to partying. It's only midnight in where you are at, so I think the day starts now. So thank you very much, Faz. As always, it has been a pleasure. Thanks.
Thank you. Likewise. Thank you.
Thank you. Well, now I want to welcome